Alright, so in today's video, we'll be taking a look at the law of conservation of mass. So that's just a fancy way of saying that mass can't be created or destroyed. So if you start with a certain amount of mass, after a chemical reaction happens, it has to be the same amount of mass. So we're going to do a little lab that's going to involve a chemical reaction. And just for some vocab words right here, what I wrote in black, all these chemical formulas, this is what we call a chemical equation. And on the left side of the arrow, we have our reactants. So that's what's going to be in the reaction. And on the right side of the arrow, we have our products. So that's what we're going to be making from the reaction. So this is going to be a reaction between vinegar and baking soda. And our products from the reaction are going to be sodium acetate, water, and carbon dioxide. So if the law of conservation of mass is correct, our mass at the beginning should equal our mass at the end. And if you take a look, this is a completely balanced chemical equation. So you can take a look. Our sodiums on both sides will be the same. We have one sodium on both sides. Our carbons on both sides will be the same. So we got carbons, we got 1, 2, 3 on this side. 1, 2, 3. We can take a look at our hydrogens. 1, 2, 3, 4, 5 on this side. 1, 2, 3, 4, 5 on this side. And then the last thing we got to take a look at is oxygen. So if we take a look at our oxygens, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we should have the same amount of mass, or even the same amount of elements on one side of our equation as the other side of the equation. We can see that's true for this case. All right, so in this lab, if you take a look at our chemical equation, we have our reactants, vinegar and baking soda. And I've already measured them out here. So this is some vinegar, which is bought just out of Walmart. It is household vinegar, which is actually only 5% vinegar. So by adding 100 grams, I'm really only adding about 5 grams of vinegar. So that's our vinegar. And then I have 5 grams about of baking soda. And I put that in a balloon. And those are our reactants. And what they're going to make are sodium acetate, water, and carbon dioxide. So when I add them together, we'll see a reaction. And we'll see a lot of carbon dioxide forming. So first thing I'm going to do, I'm going to measure the mass of these together. So let's see. Looks like it's not quite 200. So so 180 something. Let's take a look. So I'm going to say 187. 187.6 it looks like. So we need to know a little bit of physics for this lab to work, so I'm going to explain it right now. in the atmosphere, it's really, really hard to measure mass using a scale. So as I pour the baking soda into the vinegar, we are going to see the reaction, and we'll notice that the scale appears like it is losing mass. When in reality, we know because of the law of conservation of mass, we have the same amount of mass before and the same amount of mass afterward. So what we're going to try to do is we're going to take the mass before, the mass afterward, and that will be, the difference will be carbon dioxide. So that's what we're going to try to figure out. What's the mass of the carbon dioxide that we are putting into this room right here? So let's start the reaction. I'm a little bit scared. I'm gonna make a mess like I always do. Let's try it out here. I'm gonna hold this balloon down so nothing happens. Alright, maybe I'll take it off the scale just for a little while. Oh, that wasn't so bad. Alright, so in the balloon now is all that carbon dioxide that we just made. And you can see, you can take a look, we're still making a little bit more carbon dioxide, so maybe we'll leave it sitting there for a little while. But we can start measuring the mass and see how this mass has changed. So this is kind of floating up here. So even though that mass exists, this balloon's floating up here, so even though this mass exists, the scale's really bad at measuring it. We do not have a very good scale at measuring the mass of gas right here. So instead, we can measure the mass of carbon dioxide by how much mass has left. So the balloon's mainly here. Just to prevent a huge mess from happening. So we're going to release our carbon dioxide now. Alright, so there it goes. Put the balloon back here, and now we can measure the difference, and we can see how much carbon dioxide that we made. So let's see what our mass is now. All right, that looks pretty close, 185.5. So in this simple reaction, we actually produced about 2.1 grams of carbon dioxide. And we would know that because we know the mass of our reactants has to equal the mass of our products.